Κυρία Μπούρα, είστε η επόμενη ομιλήτρια. Εκπροσωπώντας την Ericsson, η κυρία Μπούρα είναι Head of Strategy Execution Region Mediterranean της Ericsson. Η Ericsson, για όσους το ξέρετε, εδώ και 4 χρόνια είναι η πρώτη η οποία μίλησε όχι μόνο για όνειρο, αλλά και για νούμερα. Είπε το περιβόητο νούμερο των 50 δισεκατομμυρίων δικτυωμένων συσκευών. Συνεχίζει και το πιστεύει, απόδειξε ότι η κυρία Μπούρα είναι εδώ και θα μας πει λεπτομέρειες.
Ευχαριστώ πολύ για την εισαγωγή. Καλησπέρα και από μένα. Να ευχαριστώ πάρα πολύ τους διοργανωτές που μας κάλεσαν εδώ να καταθέσουμε τις απόψεις μας για το Internet of Things. Θα μιλήσω σήμερα λίγο για το machine to machine στο Network Society. Και από εδώ και πέρα θα το πάρω στα αγγλικά για να τηρήσω τους χρόνους, συγχωρήστε με, μου είναι πιο εύκολο. Ας δούμε λίγο το όραμά μας. Our vision in the Network Society is that Network Society is a society where people, knowledge, devices and information are connected, are networked between each other in order to bring growth to society, life and business. And having said that, we are lucky because we are living in very interesting times. There is an unprecedented pace of change that is happening right now. It took us about 100 years to reach 1 billion places, connected places with fixed telephony. It just took us 25 years to reach 5 billion connected people, and today we are at about 7 billion, more or less the Earth's population. But we are we are foreseeing that by 2020, we are going to have 50 billion connected devices. And this is what exactly my colleague before said. But this does not come without any challenges, because, of course, the networks of today are built for transmitting basically voice. Recently, we have seen a lot of data. Actually, data traffic surpassed voice for the first time in Q4 in 2009. And since then, we see almost doubling of data traffic each year. So it's an exponential growth of data. And this represents a very important challenge for the networks of tomorrow. Then we will see a massive growth in connected devices. And this is totally different for connecting people, because we are going to see hundreds of thousands or even millions of devices connected at once in one network. You understand what kind of limitations and problems this can introduce if the networks are not prepared adequately for that. And of course, there is a wide range of requirements and characteristics, because there is requirements on speed and latency, and we will see more about that in a moment, about the energy consumption, and about the coverage. In the coverage, we have been used to talk about population coverage so far. However, now we're talking about application coverage. For example, voice, if I am from a base station 2 or 3 kilometers from the base station, I can have a very good voice quality, and that's no problem. And even if I load the cell with thousands of people or with hundreds of people. However, if I want to download a high-definition video, maybe I have to be at only 100 meters radius from the base station. So you understand, it's a breathing network. You don't have anymore this notion of, I have covered all the population, I have the base stations I need, and I'm okay. No, this changes dynamically depending on what kind of applications the users are using on your network. And of course, all this has to be affordable and sustainable. Let's take a look now at the type of connected devices. We talked about 50 billion in 2020. It might be even more than that. However, there are certain, categories of devices that we can see connected, that they have different requirements on the network and on the communication that they require from the network. We have the meters and sensors, so like sensors, actuators, health devices, and so on. Usually these are devices that are usually stationary. You don't have so much mobility. They don't have high requirements in terms of how much data they need to transmit. Usually they transmit rarely, not so frequently, and low volumes of data. They are low cost, they are small and simple, and they have a low energy consumption. Then you have, and these kind of devices, meters and sensors, are really being taken care of very well today on 3G, in 3GPP, as Mr. Magler has mentioned, standardization, and the current technology of 3G and LTE and so on. Then you have intelligent transport systems. This is a complete new segment. The automotive industry, actually, machine to machine, it is today represents about 30 to 40% of total machine to machine cellular shipments. And it is foreseen by 2018 to cover for 50% of the whole machine to machine devices that are going to be sold worldwide. So it is a very important segment. This is characterized by other types of attributes. Very high mobility, because it's installed in the cars, of course. It needs to have the capabilities to include safety-related devices. Low delay. You cannot afford to have very long delays, because you talk about cooperative cars. You talk about, we have made experiments with Vodafone in Germany in a European project just a couple of years ago about cooperative cars. And this means that cars can be able to talk to each other while they are on the road and exchange vital information about the condition of the road, the traffic conditions, maybe emergency vehicles that need to pass by, and so on. And this poses other types of requirements on the networks. And then you have the critical communication part, which is the high-end, so-called part of the device communications, where you need very high reliability, very high availability. You cannot afford to lose not even one data transmission. You need a very low delay, and we are going to see about that. And you talk about autonomous operation. This is when we talk about emergency services, how can I say, surveillance services, police, ambulances, and this kind of communication. So we have the introduction of the machine-type communications, as we say. And in this case, you need to balance between two ends. The one end on the left is about simple and cheap type of communication, low energy consumption, small data volumes. If I have a utility smart meter in my home, it only needs to transmit maybe once a month, very low volume of data. It needs, of course, to pass by, but I don't care if it takes 1 minute or 1 hour. It just needs to arrive at the operation center of the E, right? While on the other side, you have the critical communication, where you need 1 millisecond end-to-end latency. This is a very strong requirement on the networks. Today, it's difficult to achieve that with today's technologies. Ultra-reliable and highly available. So you need to be able to build networks that are able to support these contrasting requirements, and these in big, massive numbers of devices. So it is two aspects that I would like to take in relation to this. One is the network architecture, and how does that need to change in order to be able to serve this kind of requirements. And the second one is the type of technology, underlying technology, connectivity technology, that we will need to be able to fulfill all these requirements. So today's situation is what we see here, where we have vertical silos per industry. So you have for the automotive, for the freight transport, for utilities and energy management, for surveillance, for health, and so on. And then you have the access network, of course, down there. It could be fixed, it could be mobile, and so on, and the connectivity management. And this is good as long as you don't have big numbers of devices to serve. Because at the moment you start talking about hundreds of thousands, or millions, or billions of devices, this model cannot take you very far away. Or if it does, it is not going to be cost efficient, it's not scalable enough, and it is going to cost you a fortune, right? So we need to transit towards a more horizontal network architecture, whereby you introduce an intermediate layer, which is the machine-to-machine service enablement layer, and which takes away the complexity of the different industries that you need to serve with the applications. So it exposes application interfaces to the application developers' world in a way that they can continue developing applications that can be used in the different industries in a very easy way and not complex. And at the same time, it disconnects with the network complexity down on the bottom with the access and the connectivity, because also there we have a lot of dramatic changes happening. We have cloudification of the network as well, and this needs to be separated from the upper layer of the applications if we are to have scalable, cost-efficient, economic networks that can really deliver on the business case for serving 50 billion connected devices. Ericsson, if I just give a few words about Ericsson, we do have a holistic end-to-end machine-to-machine approach. We do have the M7450 multi-mode modem that can support all types of connectivity technologies today, 2G, GPRS, 3G, 4G, LTE, LTE Advanced. We do have consultancy services like the network impact analysis, because as I said, when you are introducing connected devices, you need to make a change in your network, even today, even before you arrive to the horizontal structure. We have the Ericsson Device Connection Platform, which is is offered as a service, and it can provide, for example, to an operator of today, in less than 2 months, they can launch service by using this platform from us to enterprises that are interested in offering machine-to-machine services to their customers, and they can do that even worldwide. As an example, I can bring the example of the Volvo Connected Cloud. Volvo Cars has selected this platform from Ericsson in order to they're equipping their Volvo cars from the factory already with SIMs. We collaborate with Gemalto for that. We do system verification at the factory, and this is another service we have. And then they ship worldwide, and they are sure they know in advance that the cars are going to be connected. They know the cost in advance. They know what kind of service they can offer to their subscribers, no matter if they buy the car here in Greece or in Asia or in the US. And this is very important for global players like the automotive industry. Of course, the machine-to-machine service enablement platform that I mentioned before. Then you don't need to forget also that you need business support systems, that they need to also evolve to be able to support this type of connections, because now you're talking about customer support of thousands or millions of devices. And maybe you have one company that has hundreds of thousands of devices, and they need to be supported with a different customer care than it was supported when you have to do with one-to-one subscribers and so on. And of course, managed service, as I mentioned before, and so on. This is very important. Then, just to round up, to come to with what Dr. Maglari said before, the technology. So one is the network architecture, that we need to go horizontally and remove the complexity. The second thing is the connectivity. And the connectivity that we have today with 3G and 4G and LTE advanced, it is not enough to support the needs that we are going to see with all this massive data that is going to become available from all these billions of connected devices. Therefore, 5G is being researched right now as we speak. We expect it to be launched in the 2020 timeframe. It is an evolution of existing standards, as you see here, plus complementary new technologies that are being researched as we speak. New wireless technology. We're talking about also capillary networks and so on. And Ericsson is quite active into that, because the biggest EU project right now on 5G is called METIS. It is consisting of 29 partners. Ericsson is the project leader of this project. And we have also the National Kapodistrian Athens University that is part of this effort. And as you see, most of the countries are involved into that, and they're trying to make a technology research and align industry and regulatory bodies around 5G. And having said that, I will finish up by showing a video. I was thinking, how can I inspire us a bit to think a bit how life could be, not in 2020, but in 2030. If we can please show the video.
The water volume in my shower is based on the city's consumption patterns. So it's automatically recycled within each building's filtration system, and all excess water is traded back onto the city marketplace.
My coffee machine talks to my alarm clock. My fridge orders milk before I run out. And my online food store in the virtual mall syncs with my shopping list, fridge, and others who live in my house.
So my windows, they have these little invisible solar panels that generates a surplus of energy each month, and I automatically give that away to charity.
My hydrogen car drives itself. It's connected to both the traffic system and all the other cars on it, effectively ending all traffic jams and accidents.
My food comes from enormous urban farms that soar 50 stories into the sky. Each plant has its own wireless sensor that communicates needs in terms of water, lighting, and temperature.
All the food I produce is logged via an app to the distributors in my area. All food is accounted for and sold. Nothing is wasted.
You know what's great? My phone can identify an exact product, order it, and have it delivered within a few hours.
My virtual doctor can diagnose most injuries remotely and then automatically prescribe treatments and remedies.
My app can translate languages in real time, so it eliminates all language barriers.
My 70-year-old grandfather has daily face-to-face conversations through a simple interface with me, his friends, and with my family, even though we're miles apart from each other.
Before, I had less time to connect with people close to me, and now, thanks to the time saved by new tools like connectivity, I can eat dinner with my kids, watch old films with my wife, and play soccer with my friends.
My park is lit by artificial sunlight. The trees have, like tiny wireless streams of fiber running through their trunks that sort of organically adapt like nature, which give coverage to where it's needed the most.
All of the stories you've just heard are based on Ericsson employees' visions of the network society in 2030. What's yours?
And with this, just to close round-up, thank you very much. Συγγνώμη για τα αγγλικά και πάλι, ήταν πιο εύκολα για την ταχύτητα. Ευχαριστώ πολύ.
Ευχαριστούμε πολύ την κυρία Μπούρα. Κυρία Μπούρα, δεν γίνεται όμως αυτό το πράγμα να σας κυνηγάμε από δεκαετία σε δεκαετία. Έχουμε κουραστεί πια. Πηδάμε δεκάδες χρόνια.